Hello everyone. In this video, I'm going to solve some sample problems on Newton's second law, circular motion, and friction. So let's see one by one the following questions. The first question is read as follows. A 1000 kilogram car is moving 90 kilometers per hour around a horizontal and banked curve whose diameter is 0.18 kilometers. What is the magnitude of the friction force, okay, required to keep the car from sliding? So in this question, we have to know first what are the givens, what is asked, and what is the right strategy to solve this problem. So I can write the following, okay? I have to know what are my givens first, okay? My givens are the following. So a 1000 kilogram car is, this is the mass of the car is 1000 kilograms, right? And then it's moving at 90 kilometers per hour. Okay, 90 kilometers per hour is the velocity or the speed of the car, which is 90 kilometers per hour. This is another important thing. All right, and then the radius of this embanked curve is radius is given by 0.18 kilometers, right? What is the magnitude of the frictional force required to keep the car from sliding? So it's required, okay? We are looking for a frictional force. Small f is question mark, all right? So before directly solving this problem, we need to have some conversions, okay? We need to have some conversions. So we need to convert everything into SI units, and then we have to know the relation between the radius and the diameter, because look, this one is given in the diameter, so this is diameter, okay, d, sorry, this one is d, and then we will find the radius, because solution, okay, let's go to the solution, okay, to the solution. All right, so the appropriate formula for this one is, this is a circular motion kind of problem. So when something is moving in a curve or in a circular path, okay, um, frictional force is in this case responsible for the car to maintain, okay, to maintain a circular motion. If it was not for the frictional force, it would have been slided away from the road. So the solution is given like this, okay? F is equal to, okay, mv square over r, okay? mv square over r is the centripetal force. So the centripetal force is now as a result of friction, okay? We can have different sources of centripetal force, but in this specific case, the frictional force is mv square over r, and then that is the frictional force. I'm going to calculate this one. So the mass is given, the velocity is given in kilometers per hour. I have to convert this one into meters per second, okay, into meters per second. So when I have kilometers per hour, always, if I want to change this kilometers per hour into meters per second, all I have to do is divide by 3.6, okay, 3.6. So if I divide 90 divided by 3.6, it will give me automatically 25 meters per second. They are equivalent, okay? Divide this 90 meters per second by 3.5, okay, by 3.6, okay? So we can convert that simply into meters per second. And then if we want to convert the meters per second into kilometers per hour, you can multiply this by 3.6. Again, this one is simply equal to 0.18 kilometers. So this is diameter. The relation between radius and diameter is radius is half of the diameter. So this is going to be equivalent with the radius is equal to 0.9 kilometers, okay, half of it. And again, I have to convert this one into meters. Kilo means 10 to the power of 3. This is simply 900 meters, okay, 900 meters, because kilo is 10 to the power of 3, and then that's 30, and then it's going to give me 900. This point will move to the right 3 decimal points, okay? Now I have everything ready. So you need to brush, if you forget the conversion, you need to brush that knowledge, okay? brush up that knowledge. So F is equal to now 1000, I'm sorry, 1000 kilograms times the velocity is 25 meters per second, the whole square, over the radius is now 900 meters, okay, 900 meters. So this is now, if you calculate a little bit, this is going to be 1000 kilograms times 25 times 25 is 625 meters square per second square, okay, over 900 meter, okay. Now this is going to be, if you use the calculator, this is about 6000. Use your calculator and then check it, 250 newtons, okay. So you can simplify it to 0 and then just when you multiply it and divide by 9, you will get 6250 newtons of force. So the important point here is you have to know the formula. You have to know the formula. The formula is this one, okay. The formula is this. And you have to remember to convert this kilometer per hour into SI unit, which is 25 meter per second. When you convert this, always divide kilometers per hour into by 3.6 to get the meters per second. Again, the diameter is 0.18 kilometers, and then half of it is 0.9 kilometers. Still, again, you have to convert that kilometers into meters by multiplying by 1000. So finally, you plug in the numbers, and then you will get the answer, okay? So this is one question, all right? The second question is talking about this box, okay? The second question is talking about, so a 30 kilogram box, this is a box being pushed along a horizontal smooth surface. The pushing force is 20 newtons directed at an angle of 25 degrees below the horizontal, okay, below the horizontal. What is the magnitude of acceleration of the crate, okay? So this is, again, it's always to have the diagram to understand the question, okay? So this is a horizontal surface, okay? This is a horizontal surface. So my box is somewhere here, which is the 30 kilograms, right? This is 30 kilograms, right? 30 kilograms box. So this is the horizontal surface, and then something, let's say you can push it below the horizontal. Just you can take any horizontal line here. Let's say, for example, you can take any horizontal line here, right? If you push this horizontal line at 30 degree below the horizontal line, 30 degree, this one, right? This is 30 degree, right? This one is 30 degree, all right? So if you remember, there is translation of vector. We can translate vectors. This can be changed as another force going this way, right? It's the same as this one, right? So this angle is the same as this angle, which is 25 degree. I'm sorry, this one is 25 degree, right? This is 25 degree, all right, 25 degree. Now, this push force 25 degree below is the same as this pull force at this point, 30, this is 20 Newton, all right, 20 Newton, and then 25 degree, 30 kilograms. Okay, so this is the diagram, okay? Now, what I'm gonna do is now, this force 20 Newton has two components, okay? Two components, the F of Y, the vertical component, and then the horizontal component, F of X, right? So the X component force is the one that is responsible for the movement of the crate, okay? The X component is responsible. So if I apply acceleration of the crate is asked. So if I apply this Newton second law, F net is equal to mass times acceleration, okay, mass times acceleration. But the net force is now, well, nothing is, well, this is smooth surface, there is no friction, okay? If there is no friction, there is nothing retarding this box, okay? There is nothing that retards the motion of this object. We assume the friction is just almost zero. Friction cannot be zero, but we assume that friction is zero. So the horizontal component of the force that is responsible for the motion of this object is the F times the cosine of the 25 degree, all right? Okay, because this is the adjacent, okay? If we have this triangle here, this is the adjacent line, okay? That's the one responsible, and then the angle is here 25, that's cosine of 25 degree, and then this is equal to mass times acceleration, which is 30 kilograms times the acceleration. Okay, I don't know the acceleration now, I'm gonna calculate. So from this, the acceleration is simply, I can do that, the F is 20 newtons, this part, okay, 20 newtons times cosine of 25 degree, all right, over 30 kilograms, okay, and then acceleration is equal to, now you can apply the calculator or use the calculator, and then you can get cosine of 25 degree and then 30 degree, everything is in. So you could just go back, and then the tap is 18 newton, 18 newtons, right, over 30 kilograms. This is equal to, well, the newton is the newton, the unit newton is kilogram meter per second square, right? And then you have the kilogram at the bottom. This is kilogram, will cancel, and then finally you have meter per second square, which is the unit of acceleration. So if you calculate this one, 18 divided by 30 kilograms, you will get 0. You can check this one on your own. 18 divided by 30, which is 0.6. Let me double check this one. 18 divided by 30 is 0.6 meters per second square. Well, this you can double check this by yourself. So anyway, the main thing is this. The main thing is this. The mathematical part, you can use the calculator and then check yourself. But you have to understand the problem. Okay, this is a box being pushed by a 20 Newton force below the horizontal. So that's the angle below the horizontal. So that is the same as this one by the vertical interior angles. If I push it this way, that means I'm pulling it this way, the same thing. Okay, this is the push force, and then that's exactly the same at the pull force this way at the same amount, and then the angle is 25 degree above this horizontal line here. Okay, then the x component is the one that's responsible, because this vector 20 Newton has two components, the y component and the x component. So the x component force is responsible for the motion of the box, and then that's F cosine of 25, and then that's mass times acceleration. The mass is there, 30 kilograms, and then you are looking for acceleration. Acceleration is then divide both sides by 30 kilograms, and then finally you just divide and you get this answer. Okay, so I hope you enjoyed this video. Next time I will see you in another video and other similar problems.